The year was 1912. The world watched in awe as a giant of the ocean prepared for its first journey. This was the Titanic, a ship so grand, so advanced it was more than just a vessel. It was a promise, a symbol of human achievement and a testament to the power of technology in a new and exciting century. People called it unsinkable. It wasn't just a nickname, it was a deeply held belief. The ship was a floating city, a masterpiece of engineering designed to conquer the mighty Atlantic Ocean with grace and power. Everyone, from its builders to its passengers, felt a part of something truly historic. A moment when humanity seemed to have mastered the natural world. This feeling of invincibility was not just public opinion, it was rooted in the ship's design. The Titanic featured a double-bottomed hull and was divided into 16 watertight compartments. The builders explained that the ship could stay afloat even if 4 of these compartments flooded. This design was revolutionary, a marvel of safety engineering that made the idea of the ship sinking seem almost impossible. But deep within the very structure of this magnificent vessel, a hidden story was waiting to be told. It was a story not of grand designs or powerful engines, but of the tiny, unseen world of atoms and molecules. An invisible weakness, forged in fire and steel, was about to meet its ultimate test in the freezing darkness. To understand what went wrong, we have to look closer, much closer. We have to journey into the heart of the materials that made the Titanic. The ship was built from millions of steel plates, held together by about 3 million rivets. Rivets are like small metal pins that are heated until they are glowing hot, then hammered into place to join the steel plates. On the surface, this was the strongest construction method of the time, but the science of today lets us see what they could not. We can now analyze the very chemistry of the materials they used. Scientists who studied pieces of the Titanic recovered from the ocean floor made a surprising discovery. The steel used to build the ship's hull was not the same as the steel we use today. It had a high amount of sulfur, an element that can make steel brittle, or easily breakable, when it gets cold. Think of it like this: a piece of warm plastic can bend, but if you freeze it, it can snap. In the icy waters of the Atlantic, the Titanic's steel became less flexible and more fragile. The story of the rivets is just as important. The rivets used for the central, strongest part of the hull were made of steel, as planned. However, in the curved areas at the front and back of the ship, the builders used rivets made of wrought iron. This was not the best quality iron. It contained a lot of slag, which is a glassy, leftover material from the smelting process. This slag created weak spots within the iron. Imagine trying to build a strong chain, but some of the links are made of weak, crumbly clay instead of solid metal. On the night of April 14, 1912, the Titanic entered a vast field of icebergs under a moonless, star-filled sky. The ocean was eerily calm, which made spotting icebergs even harder. Lookouts searched the darkness, but they saw the colossal mountain of ice too late. The ship was moving too fast to turn away completely. It wasn't a head-on crash, which the ship might have survived. Instead, the iceberg scraped along the side of the Titanic, a long, grinding impact that lasted for about 10 seconds. It was a fatal blow, delivered with the immense power of a moving mountain of ancient ice. This is the moment where the hidden science of the ship's materials became a matter of life and death. As the iceberg's jagged underwater edge pressed against the hull, the steel plates did not bend or tear as modern steel would. Instead, in the freezing water, the high-sulfur steel became brittle. It didn't deform, it fractured. The immense pressure from the iceberg caused the steel to crack and break open. The ship that was supposed to be strong and flexible enough to handle the ocean's challenges proved to be as fragile as glass in the extreme cold. At the same time, the ship's weak rivets failed catastrophically. The pressure from the impact put enormous stress on the seams holding the steel plates together. The heads of the wrought iron rivets, weakened by slag, popped off. One by one, they snapped under the strain, allowing the steel plates to separate. Water didn't pour through one giant hole. Instead, it rushed in through a series of long, narrow gaps where the seams had burst open along the ship's side. The watertight compartments, the ship's greatest safety feature, were breached. The iceberg had opened up 6 of them, 2 more than the ship could handle, and still stay afloat. The failure was a cascade. The brittle steel cracked, and the weak rivets gave way, allowing the freezing Atlantic to flood into the ship's hull. The sinking of the Titanic sent a wave of disbelief and horror across the globe. How could the unsinkable ship, the pinnacle of modern technology, lie at the bottom of the ocean? In the immediate aftermath, the world searched for answers. The first inquiries focused on human error. The ship was going too fast, there weren't enough lifeboats, the warnings about ice were ignored. These were all critical factors, of course, but, the deeper, more fundamental questions about the ship itself remained unanswered for decades. The full story was locked away, 2.5 miles down on the dark, silent floor of the Atlantic. It wasn't until the wreck of the Titanic was discovered in 1985 that the scientific investigation could truly begin. Underwater vehicles could finally visit the ship's grave, collecting images, data, and even physical pieces of the hull. This is when materials scientists and metallurgists became the key detectives in this historic mystery. They took small fragments of the ship's steel and rivets back to their labs. There, under powerful microscopes and through chemical analysis, the Titanic began to give up its final secrets. The truth was not just about what happened that night, but about how the ship was made. The laboratory tests confirmed the theories. The steel was indeed brittle at low temperatures due to its high sulfur content. This was a common characteristic of steel made during that era, but its deadly consequences were not yet understood. Researchers performed tests where they would strike samples of the Titanic's steel in freezing conditions, and it shattered without bending. They compared it to modern steel, which would dent and deform, but not break. The analysis of the rivets revealed the other half of the story. Scientists found that the wrought iron rivets were full of slag, just as suspected. Computer simulations using the exact chemical makeup of the rivets showed how easily their heads would have popped off under the stress of the collision. The combination of brittle steel and weak rivets created the perfect recipe for disaster. This wasn't just a story of a ship hitting an iceberg anymore, it was the story of a catastrophic materials failure. A lesson learned too late about the invisible properties that govern the world around us. The tragedy of the Titanic became a powerful catalyst for change. It was a brutal, heartbreaking lesson, but one that engineers and scientists were determined to learn from. The disaster forced the entire shipbuilding industry to re-examine its practices, from the way ships were designed to the very materials they were built with. One of the most immediate and lasting changes was in the science of steel. The discovery of the Titanic's brittle hull pushed metallurgists to develop better, stronger, and more resilient steel alloys. They learned how to control the chemical composition of steel more precisely, reducing impurities like sulfur that made it weak in the cold. Beneath the waves, the Titanic rests, a silent witness to lessons learned. From her story, shipbuilders forged a new era, stronger hulls, safer journeys, and hope for every voyage. Out of tragedy came progress, lifeboats for all, vigilant patrols, and a promise: safety above all else. As the sun rises over the sea, the Titanic's legacy endures, a beacon of hope, reminding us that from the depths we rise stronger, and every dawn brings new possibilities.